Hello, everyone. Welcome to today's webinar. I'm Ramona Della Plaza, a knowledge broker with the National Environmental Science Program, or NESP, Climate Systems Hub. The Hub is one of 4 multidisciplinary research hubs within the Australian Government's NESP program. The NESP Climate Systems Hub is an applied science partnership of Australia's leading climate change research and decision-making agencies. Our co-design research aims to directly inform decisions, policies, and climate adaptation responses, and also is advancing knowledge of future climate and extremes to help create a climate resilient Australia. So welcome again to today's webinar. Hopefully you can all hear us and you can see me. Firstly, I'd like to acknowledge the traditional owners of the lands where we're meeting today. I'm on Wurundjeri country, and I would like to pay my respects to elders past, present and emerging. We'd also like to acknowledge the lands of the Pilbara, where that we'll be hearing about today, and the traditional owners that have taken care of that country. So we have a range of speakers today. Today we'll be hearing a great example of some co-design research that the Hub has conducted on applying a storylines approach to water management in Western Australia, in the Pilbara catchment, as we mentioned, but also more broadly with some work that DWER has done. So we'll hear from our speakers. We'll allow some time for clarifying questions after each talk. I encourage you to write your questions in the chat, vote on the questions as well, and we'll do our best to answer them. Then after we've heard from all our speakers, we'll have some more time at the end for discussions and questions. So really looking forward to a good discussion at the end. So without any more delay, I'd like to introduce our first speaker that we have today, Sagat Nasi from the Bureau of Meteorology, who is a research scientist with the Hub, whose research interests include rainfall, atmospheric dynamics and climate change. Sagat will outline the storylines approach and how it can be applied to climate projections. So thanks, Sagat. Please share your slides and start.
Great, thanks, Ramona. I'm just going to share my screen. Can you see that now, and is it in the correct view, or do I need to switch the views?
Yes, it all looks good. Thanks, Sagat.
Okay, great.
Thank you. Okay,
great. Yeah, so before I get going, I just want to acknowledge Ramona and Tani for their efforts with organizing this this webinar, and also for their massive efforts in getting the report and the fact sheets ready, which I guess Tani's going to put a link to in the chat at some point today. Okay, so this talk is titled Climate Change Storylines, and it's about a case study of the Western Pilbara water resources at the local catchment scale. In this short talk now, I'm going to try and emphasize the co-design elements, so I'm not going to go into great detail about the sort of the underpinning or foundational science for storylines. We've had other events where we've talked about that, but this is very specifically about this case study, which was meant to be applying this sort of new and innovative technique, or what we think is a new and innovative technique, to important problems for application of climate change data and information for decision making. So this wasn't all done by myself. This was a co-design with colleagues in WA, but also at the Bureau and CSIRO. I'll put their names up on one of the following slides, but I thought I'd just start with this slide here, talking about storylines and why we should consider them. So excuse my very dodgy little cartoon. This is meant to be a waterfall cascading down. And this idea is about the cascade of uncertainty in climate change information, which for most of us who work on climate change science and projections kind of intuitively incorporate into our thinking. We understand that they're uncertain by nature, but this can be very challenging when you're someone who works with climate change information but doesn't necessarily have this background in the climate science. So in this cartoon of mine, it starts at the top here with scenarios, emissions scenarios, emissions pathways, And so immediately you can see that there's uncertainty introduced into future climate information, because we don't know how emissions are going to progress over the future, or how mitigation actions will affect the future state of greenhouse gases. So there's already uncertainty, and then we run these scenarios through climate models. These climate models are great, but they produce output at sort of information at the 100-kilometer scale. And so we have downscaling models, and so on and so forth, down through impacts models, bias correction choices, and then indeed even other lines of evidence. So this cascade of uncertainty means that there are thousands and thousands, if not more, plausible future states that one must consider as plausible when making decisions with climate information. And that can be overwhelming. So how can we distill that overwhelming amount of information into something usable and useful and reliable? And storylines is one way of doing that, but really any narrative-based method can help you do that. So with storylines, we attempt to take this massive information and distill it into simple and discrete, easy to understand and easy to use information, which can be, which can quantify the implications of uncertainty, but also help us to avoid improper statistical interpretation of available information and data. So that's an important factor here with using storylines, because we honestly may not know which outcomes are more probable. Further to that, storylines can be used to motivate action and decisions by relating plausible climate change to real world experiences or impacts, or making them directly interpretable for decisions. And there's probably more. So if you go and look at the papers on storylines, you'll find some really nice discussion of why you'd want to go down this path. Okay. Oops, sorry. Okay, so I won't go into great detail about what storylines are and how they're constructed, but I guess one thing that I would like to point out, just as I guess an important aside here, is that even though storylines are in some ways subjective because you have to choose them, they're not arbitrary. They should be chosen to reflect the known influences or plausible influences on some kind of impact or decision. And one way to kind of clarify that is through causal network diagrams. So here in this diagram, I've tried to construct one for water resource planning or water availability in the Western Pilbara catchments. And you can see on the left here, you go from greenhouse gases and large-scale climate change all the way down through the ways in which climate change will impact water availability. And of course, there's still other factors like vulnerability and exposure of water resources. So when constructing storylines, we need to incorporate as much of that information as possible. And so what tools do we have at our disposal to do this? This is what this project is really about, and this is what this talk today is really about, is trying to take the tools that we have and the data that we have and interpreting it in a new way, or what we hope is going to be a more useful way through storylines. And so in that vein here, I've listed the contributors to this project on the slide, and people had different roles in this project. One of the most important and critical parts of this was the co-design process. And through the co-design process, we tap into local and domain knowledge from the next users of the projection. So I may be someone who works with climate data every day, but I really know very little about water resource usage in the Pilbara. I know very little about the local context of climate change information in the Pilbara. And so that's what people like Jackie and Margot bring to these types of projects. Of course, they also understand climate variability and change, but in combination with other skills, I think we can construct useful information here in a slightly different way. We take the process understanding of regional climate change and the drivers of climate change from the literature. In this project, that's one of the limitations of what we did. It's not very locally calibrated to local drivers. I'll come to that at the end. And we really are leveraging here this amazing, freely available data resource that anyone in the Australian public, or in fact in the public in general, can access. So CMIP or global climate model data that's just freely available. And also application-ready hydrological projections data, which is freely available as well through the Australian Water Outlook website. So that's sort of the cornerstone of this case study, was to try and use that hydro projections data to come up with storylines. And of course, we had to do a little bit of evaluation to make sure the data was fit for purpose. I'd like to shout out my colleagues listed here, Greg, Justin, Jackie, Ulrika, Michael Gross, Kelly Barnes, and Shri, who did a lot of work. And also to acknowledge Julia Minlin and Ted Shepard, who gave us advice on how to do storylines. So what did we co-design? I mean, this is an interesting term that gets used a lot, and I think it probably means something different in every project and every context, but I'll tell you what it meant in this project. So coming into this, I was interested in applying storylines to local decisions, and clearly the easiest or most obvious thing to think about when you think about water is rainfall. And so I would have probably just looked at mean rainfall changes, and that would have been the start and finish. But of course, talking to local water managers, talking to Jackie Schopf and Jackie Bellhouse here, it became clear that actually the change in runoff is what matters in combination with water demand. And really, when you boil it down, the one of the clearest ways to describe those changes, hydrological changes or hydrological impacts, was really through the frequency of wet years and the frequency of dry years and how that might change with global warming. So that sort of changed, I guess, the end point of where we're trying to get to with these storylines. And another thing I think that was really interesting and important about what happened here was that, I guess coming from a research background, I was thinking about the application of climate change storylines from a very technical perspective. And there were some technical challenges with applying storylines here, which would have meant that it was difficult to describe a particular storyline on the very extreme dry end. And so my inclination was to leave that out altogether. However, talking to Jackie Bellhouse here on the call, it became clear to me that actually that would be a much worse outcome than having a slight variation on storylines that was perhaps not exactly as others have done it, but would mean that we're able to much more completely describe or span the uncertainty range here to make sure that that very extreme dry storyline was represented in the storylines that we decided to describe. So I think that's really interesting and important because the use of the data really, the use of the storylines really informed how we constructed them here rather than the other way around, which of course is the intention of this type of exercise. Okay, I might skip this for the sake of brevity because I think I'm going to run out of time. But just to say that the storylines are not just made up over nothing. They're based on physical factors that we know drive regional climate change projections. Here, these were sort of hemispheric scale, looking at the degree of climate change or global warming in the southern hemisphere, and specifically looking at the stratospheric polar vortex breakdown and how that would affect remote places, and also the amount of warming in the upper troposphere and the tropics. I'm going to skip straight to the punchline because I think this is sort of, after all the work that we did, this is what it boiled down to. And there was a lot of other work, technical work that went into this, but in the end, it boils down to these three very simple narratives. And I guess before I say anything about them, I guess the main point I wanted to get across here is that if you stop and think about where we started from, hundreds of global models, multiple scenarios, downscaled information, downscaled data, bias corrected. These are all very technical terms that proliferate data. We've boiled it down to three simple narratives that people should be prepared for when thinking about water resource planning in this catchment. And these three simple narratives are simple to interpret. They're quantitative. They're relevant to the decisions made because they're about the quantities that matter to those decisions. In this case, the number of very wet years, the number of very dry years. And they're reliable and plausible. And they're almost representative. So that's a point that I'll come to on the next slide. I'll just read out one of them, the much wetter future. So in this storyline, global changes affect the regional rainfall. As the planet warms, if the lower atmosphere warms faster than the upper atmosphere, then the Pilbara region will become wetter. In this storyline, the tropical upper atmosphere only weakly warms, which results in much wetter conditions over the western Pilbara. Wet season runoff for the DWER catchment is estimated to increase by around 150% on average by the year 2050. Relative to the current climate, this corresponds to 225% increase in the frequency of very wet years and a nearly 90% reduction in the frequency of drought conditions. Okay, so I'll end on a slightly more negative note, but I don't think that I don't want that to be misinterpreted as meaning that the storyline is not useful. It's just a caveat and something for future work. So this case study was sort of a proof of concept to show that we can apply this interesting approach to existing data and existing decision-making processes. And one of the things we did was spend quite a bit of time evaluating what we were doing and saying, okay, have we adequately addressed projection uncertainty in this region? And the application-ready data set that we chose to use for this particular location was unfortunately missing the driest plausible outcomes and the driest storyline based on physical causes. And so, you know, that's a caveat here, that there's an extreme dry storyline that's not described by what we did. Also, another thing that's missing here is that we really didn't go into the local regional climate change drivers. And so there are probably some other factors that need to be considered, like, you know, warming of SSTs off the West Coast, for example, which are probably important, but we're not part of the storylines that we considered here. So there's definitely more work to be done. But I think what we've done really in this project is show a proof of concept. It's a tangible first step towards applying storyline approaches to application-ready data sets. And I hope that this will spark some interest and get more people trying out these new ways to communicate projections. And I really do think this is going to be a bigger part of our diet and climate projections and adaptation, purely because of the proliferation of data. We have huge data sets. We have more and more downscale model ensembles, bias corrections, and so forth, which just cascade the uncertainty further. So we need some way to process that and bring this to sort of decision relevant information. So on that note, I might end. And if anyone has any questions or wants to chat, please feel free to get in touch. Yep, thanks.
Thanks, Sagar. That was a great overview. Much appreciated. I think it was very interesting for all of us. We have time for very quick clarifying questions now. Otherwise, I haven't seen any in the chat. If you do want to write them in the chat, or if it's a quick one, put your hand up and you can quickly ask it. Just give a minute for that. Otherwise, it looks like you explained it so well, Sagar. Thank you very much. The next speaker I'd like to introduce now is Margot Turner. Margot is a senior climate change water specialist currently on secondment from the Bureau of Meteorology to the Department of Water and Environmental Regulation. Margot will discuss how the storylines approach has been applied through DWER's Guide to Future Climate Projections for Water Resource Management in Western Australia. Thanks, Margot. Please share your screen.
Thanks, Ramona. There we go. Is that coming through?
Yes, that's looking good. Thanks, Margot.
Great. Yes, so as Ramona mentioned, I'm going to talk about the Guide to Future Climate Projections for Water Management in Western Australia. I'd like to mention all the contributors to these guidelines and who are listed there from both the Department of Water and Environmental Regulation and the Bureau of Meteorology, and also give a shout out to a number of reviewers that have been adding a lot of value to these guidelines in the last 6 months, which is very much appreciated. So obviously the impacts of the drying climate have been considered in water management planning in WA for well over 20 years. And I wanted to give you just a little quick overview of, pardon me, of what's been considered in the process of integrating that drying climate assessment into water management so far. In the very early days, a long-term average rainfall for yield calculations was used, and that period was then shortened to an historical rainfall record from 1975, recognising that is when the start of the declining trend in rainfall started in the southwest. In the early 2010s, a more consistent approach for selecting and applying climate projections was developed based on the CMIC 3 generation of global climate models. And that approach formed the basis of the previous guidelines that we've been using that were finalised in 2015. And that was based on an approach of selecting a wet, medium or dry climate scenario. And at that time, the climate science modelling had already been updated to the CEMIC 5 generation of projections, and which would then to become the basis of the Bureau's national hydrological projections. So at the time of finalising the 2015 guidelines, there were already conversations about how we would need to update the projections for use in future water management processes within WA. So the collaboration between DWER and the Bureau began in about 2019. And the aim was to understand the difference between the CEMIC 3 and the CEMIC 5 projections, and ultimately produce a new guide for the water sector based on the updated projections that could be used for both internal use by water planners and also external use by our stakeholders. And this is what I'm going to talk through today. In the future, as Scott mentioned, there's always more data becoming available and updated generations of global climate models being assessed and evaluated for use in decision-making processes. And this is the case through the WA's Climate Science Initiative as well. And at the moment, CEMIC 6 projections are being processed and evaluated, and they'll become available in the next couple of years for use in water management planning. And this guide that I'm going to talk today about is based on a framework where new data and new projections can be used without having to redo the whole framework as a whole. And the storyline approach has really been the platform that has allowed that framework to be set up that way. So obviously, with the new generation of global climate models comes new methods and new data availability, and particularly data outputs. So I won't go too much into the detail of the modelling framework of NHP today, but I do want to highlight just a couple of things. So the downscaling and regridding through bias correction methods produces like 16 climate projections for 2 emission scenarios, a moderate and a high, so the 4.5 and the 8.5. The 2015 guidelines recommended using scaling anomalies that represented the traditional wet, medium, dry scenarios that were applicable mostly in the southwest. It wasn't recommended to apply this method outside of that region or in northern WA, just because of the climate variability in that region. So the benefit of NHP data is that it could be used throughout the whole of WA, and it provided continuous daily data for each climate and hydrological variable that's listed there. So for a total of 32 projections, if you're taking into account the 2 emission scenarios. So as I mentioned, these guidelines at the moment recommend the use of NHP data, but as the new generations of global climate models become available, the future data can be integrated into this process based on this framework. So one of the biggest benefits of the storyline approach is it just helps make sense of so many multiple climate futures. As Sagat mentioned, there is so much, many futures available to look at, and it provides a way to move away from the traditional approach of using the dry, medium and wet scenarios to an approach that considers the impact of a range of plausible futures on the climate and system drivers within a region. An improvement from the previous scaling by anomaly method is the time series also supports investigation of the impact on system features such as variability or frequency of dry and wet years or aridity or seasonal inflows. It also provides a systematic approach to integrate that climate assessment in a planning process. Now, the storyline approach itself isn't new really in terms of water managers and planners or have already been using parts of it in their decision-making processes. The framework really just strengthens that process and being able to integrate what those range of plausible futures will mean to the water management decision process. So this is an overview of the framework. I will be running through each of these components today, but I just wanted to draw your attention to the 3 different components that make up the framework. The first component has 3 steps, which helps build an understanding of climate and system drivers within a region of interest. Understanding the relationship between the climate and the system drivers helps to build that storyline narrative and the projections to use within the second step of the framework. And that second step is the climate and water assessment. So that component usually would involve hydrological modelling or any other analysis that you use to assess the impacts of a changing climate on your system. And it includes planning for adaptive management processes that may be needed to treat potential climate impacts. To move an outcome that you find through the assessment into a more desirable risk zone, for example. And finally, one of the most important parts of the process is communication. So the storyline approach provides a tool to communicate that storyline narrative that's been built up through the application of the framework to assess how the future will impact the system and how that future will be assessed and monitored as the actual climate future unfolds within the relevant planning horizon. So onto each step themselves, the framework. The first step of the framework is to build that understanding of the context of the planning decision that's being made. So as I said, water planners and managers do this intuitively as a first step. But you look at the decisions, what type of decisions being made and what information do you need to make that decision. Is there an operational lifespan of the decision that's relevant within the water planning context? Now, I've included some time horizons here that we've looked at that are relevant for water planning. And your time horizon will influence how the projections are used in analysis, either, for example, a future 30-year period around 2050 or the full time series. It's also good at this point to have considered the adaptive management processes that are available to monitor, evaluate and review the outcomes throughout the planning horizon. And also what levers are available to manage the outcome if it does move into a less than desirable zone of impact. Finally, which is one of the most important steps, what is the question that you need to answer to inform your decision? So the second part of the framework looks at understanding the water system. So the more you know about the relationship between the climate drivers and the system drivers, the better the storyline narrative will be and the better it will fit into the planning process. So as this step in the framework, it's important to look at the historical data to understand the resource, identify the vulnerabilities, the thresholds, the system priorities that may drive your planning decision, and identify the climate characteristics that drive the system. So as Sagat mentioned, it's really important to co-design this sort of planning with regional experts that ensure that the key drivers are really well understood. System drivers could include water levels for recharge, inundation levels, or average yield for water supply. Examples of the climate drivers could be the number of consecutive dry years, winter rainfalls, or catchment aridities. Those things that really you want to protect, or you know that will have an impact on the inflows that you get within the system. So the final step of that first component of the framework is to understand the potential impacts and consequences. So looking at the climate projections and summarizing measures of climate that are important to the water resource. So you draw on that information that you put together in that second step to then start saying, okay, what does that mean? What are the projections showing? So at this point, you decide if you choose a subset of the projections or use all of the projections within a climate assessment. So this will obviously also be dependent on things on time, resourcing, the amount of modelling you do. For example, if some of the groundwater modelers have commented that it takes a long time to put 32 projections through a groundwater model. So you need to really have a think about what are the important parts that you want to explore when looking at the projections data. So I've got an example here, because at this point you're really selecting your storyline projections to support your storyline statement or narrative. So an example I've got here, a water supply manager wants an estimate of the potential range in future average yield over the next 30 years. And the water manager knows that the average annual aridity and a count of 2 consecutive dry years influence the reservoir water supply. So just doing a simple plot for each of the projections showing the consecutive dry years versus the average annual aridity already starts to paint a picture of what's the impact of the plausible futures going to be on water supply. You can see that there's a group of projections up here that are expected to show the highest average supply, and also a handful of projections that are projected to show the lowest average supply as well. So you're already sort of starting to work on that narrative, and you're already starting to pick up, okay, which projections do I want to take forward in my water planning story? So you take that information on to your next step, which is the first step of the climate water assessment. So as I mentioned earlier, this step would involve your hydrological modelling or other analysis that you would use to assess the change in system drivers. And depending on your analysis, and maybe carried out at the same time as the previous step, you might go back and forth a little bit, redefining your metrics or finding or testing a few different metrics to see what really does tell that story between climate and your system drivers. So looking at the example we've got here, the water manager is looking to provide 2,000 megalitres per year to an irrigation supply. There must be a minimum of 1,000 megalitres per year for the next 30 years. So they're essentially your system drivers. So looking at the full set of projections from the NHP, it shows that most projections meet the target for that supply volume. But 5 projections show at least 1 year with less than 1,000 megalitres supply. So putting that back into the storyline context, the future climate projections with a higher aridity index and greater occurrences of consecutive dry years result in at least 1 year with supply of less than 1,000 megalitres. So obviously this is not the optimal operational supply that this water manager is looking for. So taking that information into the next step of the framework, it's really about evaluating and using the knowledge of the impacts and consequences to assess the range of consequences across the plausible futures. So looking at that group of projections that don't supply the minimum supply needed, and exploring the resilience of the water resource to impacts from different climate futures. So you're looking at, for example, from that example we've looked at before, a water manager would need to start thinking about, okay, what do I need to do to augment the supply? Do I need to redesign for a lower demand, or is there supplementary supplies that I can rely on? Or following on from that, are there contingency plans that I need to put in place to monitor and evaluate the climate as it unfolds within that relevant planning period? Because at the moment, things are fine. So, and because there are so many plausible futures that have been projected, or one way to, I suppose, monitor and safeguard the decision that's made if there is a projection that does not meet the supply is put in regular monitoring and assessment and evaluation points in place, and have contingency plans ready to go to change decisions if you need to at that time. So again, this may require going back through the steps of the framework to assess those contingency plans, and also whether targets can be reached, or what are the trigger levels to influence those contingency plans being implemented, I guess. So the final step of this future water assessment part of the framework is really about consolidating what we've learnt through establishing the relationships between the climate and system drivers, assessing the impacts and knowing what the potential impact could be, and assessing how many or what sort of adaptive management processes need to be put in place to actually include those climate futures within a planning process. So I know Jackie will go through with her talk about and talk about these stages of the framework in more detail, but I guess the points that I wanted to bring up here is that it's important at this stage to, I suppose, have a really good handle on what are the no regrets or co-benefit options that can be implemented first. What are the trade-offs that are used, that are needed if different storylines eventuate? And the other questions would be like, are any long-lasting transformational decisions needed? Or is there an incremental change that can be made? So again, when thinking about that sort of plan, act, monitor and evaluate process and how that can be implemented within a planning process. And finally, communication. This is, of course, one of the most important parts of this process. The storylines approach provides a tool to communicate how a future climate will impact a system and how that future will be assessed and monitored as the actual climate unfolds within the relevant planning process. The storylines, for example, that we use today, increased aridity in the number of consecutive dry years, do provide a context to then describe the planning options and the range of impacts for those options. And those options that eventuate will, of course, depend on the actual climate that unfolds. So in summary, water planners and managers use the storyline approach intuitively in their decision-making process. This framework helps to make sense of the numerous climate futures that are out there, increasing the awareness of climate change and impacts. The good thing about this process and the storyline approach, it can be applied across regions of contrasting climates and system drivers. And most importantly, it provides a context for communicating the planning process and the options that are available. Thanks very much.
Thanks a lot, Margot. That was again really comprehensive and a great overview of the work that you've done for the guidelines. So thanks very much for that. I can see lots of people putting questions in the chat. We really appreciate it. Sagart's doing his best to answer the ones from his talk previously. I think, given the interest of time, we might, Margot, I think unless anyone has a burning question for you particularly about the work you're doing, please raise your hand now to ask it. Otherwise, we might go ahead, because I think some of the questions I've seen are a bit broader, like more discussion type questions for afterwards. So does anyone have a question from Margot that they really would like to ask now? Give a few seconds. No? All right, I think we can move on to Jackie then. Thanks very much, Margot. Thank you. Next, I would like to introduce Jackie Bellhouse. Jackie Bellhouse is a senior hydrologist within the Water Corporation of Western Australia. Jackie will share with us the learnings from the case study in the Western Pilbara that Sagart mentioned earlier, where she's worked with the hub. Can you please share your slides, Jackie? Thank you.
Thanks very much. For those who don't know who the Water Corporation is, we're a water and wastewater service provider in WA. We cover about 2.6 million square kilometres and we have over $40 billion worth of assets on the ground. So we have a fairly strong interest in the risks that climate change present. And so did that change?
No, it hasn't. It's not changing, Jackie.
No.
Perhaps if you reshare. Or...
Hang on one sec.
It was working so well.
It was. We'll try this again. How's that looking? And
that's looking good again. So maybe just, yeah.
There we go. Okay, cool.
Yeah, perfect. Thank you.
Sorry about that, slight technical issue. So as I was saying, we've got a strong interest in the risks that climate change presents, and the work that the Bureau and Department of Water are doing in providing us with some updated climate change projections and guidance on how we can apply it. And even the work that NESP has been doing in using a storyline approach is very important to us moving forward. The stuff I'll be presenting today is a bit more of a work through of some of the case studies that we've been working in the Pilbara region. and some of the learnings that we've taken from both the collaborative work that we've been doing, but also our sort of in-house work as well. So for those who are not familiar, the little map shows roughly the area that we're working in at the top end of WA. And our question here is, what risk does climate change present to the water resources within this area? The scheme map you can see is the West Pilbara water supply scheme, but I will be covering off a little bit on what we call the East Pilbara supply scheme as well. This is a fairly resource heavy area with a lot of mining. So we have quite a few region experts and stakeholders that we interact with when we do this type of assessment. And that's everything from our domestic and industrial customers, traditional owners, our regulators, including Department of Water, our water resource managers, and also the resource companies and even state government. In this regard, we're looking at a water resource reliability. So our planning horizon is out to about 2060. And I'll be talking about 3 particular bore fields and 1 supply dam within that area. So the 4 different supply schemes that supply the 2 areas are shown on the screen. As you can see, they're quite diverse in size and how much water we have allocated via a regulator. They also have quite different flow regimes that influence the recharge into them. And then on top of that, schemes such as the dam also have additional factors that influence potential losses other than our use from the system as well. The other thing that they all have in common is that they've all got very strong cultural, socials, or environmental values, or all 3. And so we are often sharing these resources with other areas that also we need to make sure water is maintained too. So doing a resource or a climate change risk assessment on the resource becomes a little bit more challenging. And then when you tier on top of that, the sheer volume of climate projection information and its behaviour, it becomes even more tricky. So as Margot ran through the guidelines, once we've sort of gotten the idea of what question we're asking and the understanding of the schemes, we start looking at what the actual climate drivers are that influence their particular behaviours. So in this instance, a general overview of the area is that we're going to see increases in temperature, and that's including temperature and hot days, frequency of hot days and duration of warm spells. They will likely influence our demand or our clients' demand for water. But on top of that, the areas are actually influenced or recharged through cyclonic events and tropical lows primarily. And the projections say that they're going to decrease by as much as 50% in 2090, with some moderate confidence in those projections. As a result of that, we are seeing projections that predict time spent in drought will increase over the course of the century. And while changes to rainfall and runoff are possible, they're a little bit unclear, as you can see from the maps that are moving around on the left, where the blue is wetter and the brown is drier. And that's because the natural variability of that system, as influenced by the tropical lows and cyclones, has a strong signal still within the influences. So we know from the way that our schemes react to runoff and how that recharges the system, so 3 aquifers and 1 dam, that just whether the years are getting wetter or drier isn't the main driver for their ongoing reliability and ability to supply, but more the frequency and shift in the frequency of wet to dry years is important to the system. So as a result of that, and as part of our scenario planning, where we explore a multiple set of scenarios that represent different plausible futures, and you might have heard that mentioned before in the storylines approach, we actually try and have a look at how different plausible climate futures will have an impact on our ability to supply. And then we explore different adaptation pathways within that to determine what are some of the possible ways forward. How elaborate we get with that really depends on the risk that we're assessing, the consequence of it actually occurring, and the cost of those potential adaptation pathways. And as you've heard today, storylines is actually quite a strong approach to help us in compiling those fit for purpose narratives within our scenario planning. So what we're looking for is what has happened, how does it compare to what could happen within those systems. As I've already mentioned, in the Pilbara, the very clear climate features for us are rainfall, evaporation, and of course the drought duration. And what we're looking for is what the impact of a wetter, little change, or a drier behaviour are within that system. If we were somewhere else within WA, say the southwest, the concept or the view might be a little bit different, because unlike the Pilbara, the southwest is showing mostly a declining change in rainfall. So in that instance, we might look at something that's maybe less of a drying right down to an extreme drying scenario. And of course, we also have to acknowledge in our assessment that there are potential uncertainties and limitation. And Sagat's already mentioned today that there is potentially missing a plausible extreme drying within our assessment. So we have to take that into account as we communicate our assessment to those planners and help them forward with their decisions. So what's actually the climate risk in regards to these systems? So what we're seeing is the systems responding to the sensitivity in both an increase in demand and the influence of key climate factors such as drought. And then within that, we have run both complex modelling for the West Pilbara and more simplified modelling for the East Pilbara to see what the feasibility of some of our potential adaptation pathways are as well. So I have to disclose that we didn't have the guidelines when we did the West Pilbara modelling. We had only just started exploring the storylines approach, and we got given 32 climate projections, which we went a bit crazy with. So in all, the West Pilbara work has actually taken us 2.5 years to go through. So quite cost, time intensive and resource intensive as well. However, from that, we did learn about how we could narrow down those narratives. And we started using things such as the aridity and dry days and drought durations in these systems to narrow down what we actually use when we are doing our assessments. So for Yule, it took us a lot less time to come up with a similar sort of scenario analysis for that system. How that then influences how we adapt is dependent on the cost and the consequence of the risk that we're assessing. And we have a whole wide range of adaptation methods available to us. Everything from putting in a desal plant when we've exhausted all of the available water resources within an area. That has its advantages, but it also has its disadvantages. Desal can be quite costly to put in, has a significant lead time, and it not done right, it can also be seen as a bit of a maladaptation due to its higher use of energy compared to things such as groundwater or surface water. So as a consequence of that, our adaptation pathways also look at how we might also, or where we might also be able to manage the risk. And Margot covered that quite well in her guidelines synopsis as well. So in this case, for the West Pilbara scheme, while we are potentially looking at a desal for that area, we are also looking at how we can manage the risk on some of those schemes or sources where the potential risk out into the future is a little bit more unclear or potentially looking to be a little better for us, or a bit more opportunistic is probably the word I should use. So as a result of that, we put in other measures such as increased monitoring, increased management of the system as it is at the moment, and see if there is a potential for us to keep using that sort of system with a bit more sort of high level care and caution. And of course, we still keep on doing our risk assessments and revising our risk assessments in order to manage the residual risk that that potential option presents. And in light of the fact that we have a various range of climate potential behaviours that we actually have to counter for. Overall communication. What we learnt was assessing a risk under 32 possible climate futures is extremely challenging. Communicating those results to a planner or a decision maker is extremely challenging. They end up being overloaded with information, and as a result, they become increasingly uncertain about what you're telling them, and they have some reduced confidence in the outcomes. We have found that the storyline approach and sort of distilling those narratives down into some key ones is a very good approach to both setting the scene and describing the modelling that we've been doing, but also in exploring the potentially what's to come with the decision makers. In that, we're not asking just what will happen, but what is the potential impact of a particular influence and or our actions. And as Margot outlined, it's actually not new. Water resource modelers and managers have been doing components of this process for quite a while. What we probably haven't done is really written it down in any solid guideline documentation about how we take those approaches and communicated it out a bit wider to the general community. So in this instance, you can see from the graphs down below, the storylines approach can actually help us distill a lot of information, a lot of squiggly lines, down into 3 compelling narratives, which then can be used to help decision makers decide on which adaptation approach is the best for that particular system that you're looking at. And that's me.
Thank you so much, Jackie. That was a lot of great insights, and I think, yeah, it really helped to paint the picture of what the work and how it can be useful. So thank you very much, and some of the challenges also in using this projections. We have lots of questions. Thank you to Margot and Sagar for trying to answer them in the chat, because now we only have 7 minutes left. So as expected, all the great talks have inspired a lot of questions. So I think there's one that I would like to actually ask, if Nicola Johnson would mind asking her question live, if she's still here, because it's been given a lot of votes. Nicola Johnson, we can unmute you if you raise your hand and you are keen to speak. Yes, great.
Oh, hi, can you hear me?
Yes.
Yes.
Hi, Nicola.
Hi, everyone. Thanks so much for all your talks. So my question was, I guess, following on from, it seems like a great approach, the storyline approach, to communicate information to decision makers, or maybe people that don't have as in-depth an understanding of climate models and things like that. So just curious how it's been received by different stakeholders, if anyone hasn't liked the approach, or yeah.
Thanks, Nicola.
I might take that one, Ramona, if that's...
Yes, thanks, Margot. Great.
So I think, Nicola, using WA as the example, we had those 2015 guidelines were based on one approach, and obviously this storyline approach brings in a different method for water resource planners. So I think there has been some time, I suppose, needed to shift to thinking about, okay, we don't just get given 3 metrics, you actually have to look at the projections and then think about that storyline narrative about the impacts of each of those projections over a range of plausible futures. So it has taken some time, I think, for understanding that approach and being able to apply that within existing processes. But as Jackie said, and reiterated in her talk, it's a lot of these components are already done by water managers. So it's great to be able to draw that out a little bit more with this process, I guess.
Thanks, Margot. Did anyone else want to add anything, Sagar or Jackie? No? No? Thanks, Margot. That was a comprehensive answer. I think there was also in that has already been answered so efficiently, but I think there was also a question about how stakeholders have reacted to the extreme wet and the extreme dry scenarios. And I think, Jackie, you mentioned also in your work that, the extremist, the very extreme dry is maybe not be considered. Can you give us any suggestions on how you might handle that?
So probably acknowledge it to start with, and how they handle extreme wet versus extreme dry does depend on sort of source to source, area to area, and what the overall influence is. I think you could see in some of the graphs, for instance, Harding Dam pretty much has a high risk across most of the scenarios anyway. So that decision in that area is not as challenging, say, Perth FAPS, as it is for Yule, where it's facilitating on the other side of it. So some of the reactions would be where you've got sort of a split decision, might be to manage the system better, monitor it better, keep understanding how it's behaving, keep an eye on the climate behaviours, and also understand over what time frame they're projecting the change as well, so that you can understand how critical your decision actually is over that time frame, and whether you can maybe hold for a little while just to see, if things are changing or moving, if we're seeing a stronger single one way or the other.
Thanks, Jackie. That's really helpful. Did anyone else want to add anything to that? No? Okay. Would anyone else like to, we have 3 minutes left, anyone in the audience would like to raise their hand and ask another quick question? Again, thank you, Sagat. You had a lot of questions that you have, typed out very comprehensive answers to. I encourage everyone to have a read of those. Oh, Jeff. Jeff's on the line. Jeff, would you like to raise your hand and ask your question? Jeff Steenman from Victorian Government, former colleague. So welcome, Jeff. If you'd like to ask your question.
Oh, hi. Sorry, I was trying to figure out how to unmute, but thanks for the great talks there. Really interesting. So yeah, I was just interested in
we're having a bit of trouble hearing you, Jeff. We could hear you fine, and now we can't.
Okay, I was just interested. Yeah, I was just interested in the sort of ability to compare across, say, different water systems, and if they're what the experience was with the storylines approach in being able to sort of compare across different systems. I could imagine, particularly in WA, you'll have very different climates, potentially very different storylines you might be looking at north to south. So I was interested in that aspect.
Yeah, so we do have 3 distinct climate zones, but within those, there's some distinct behaviours within them as well. We're really only going down the path of sort of doing intercomparison between our different sources and understanding behaviours. Climate Change Australia, CSIRO, does give a very good sort of overview of that sort of regional expected behaviour, but those comparisons that we've done inter-source within those regions have shown that they also have their own particular local behaviours as well. So it is quite tricky. And it's probably something that you can really only do once you've built up a bigger understanding of each of the local and individual areas as well. And for us, that's still a work that's ongoing. But at a general level, what we've found so far is that they do tend to reflect that sort of higher overall summary in a very, very general sense, but with their own sort of particular behaviours as well.
Can I just add one thing on top of that? Sorry, Ramona, we're running out of time, I know. Jeff, that's a really good question. And I think one of the powerful things about Storyline's approach is the ability to address correlated risk questions. And so when you have, so for example, maybe the worst case scenario is in the north, you get an extreme wetting, and in the south, you get an extreme drying. Well, if those risks have some type of correlation, so they never occur in any physical system that's simulated, then you kind of want to know that. And you do that through a Storylines approach because you address the correlated risk on whatever grounds that you think is important. So if you have multiple areas that are important, you put that into the right side of your causal network. and you work your way backwards to find out what is physically plausible. So yeah, I think it is. I think it is doable, but as Jackie said, you're trying to measure.
Thank you. Thanks everyone for those great questions and the comprehensive answers from our speakers today. Really appreciate it. I think it's been a great, we can all say it's been a great presentation. I can see some lovely acknowledgements of that coming up in the Q&A. So I think we're probably out of time now, so we'll just have to wrap up. If you have any other, last minute questions to put in the chat, we'll endeavour to try to answer them. But thank you very much to all the speakers. So to Sagat, Margot and Jackie, really appreciate it. As we said, thank you again for Tani in the background for your help, and everyone for attending. We've had a really great turnout today. So just wanted to say thanks very much, and I look forward to the next webinar from the Nest Climate Systems Hub. Thank you. Thanks everyone. Have a great day. Thanks. Bye.
Thank you.